So in this final segment, we'll conclude our discussion of the risk management process. We'll talk about risk evaluation, risk control, residual risk, and we'll have some comments at the end as we conclude the discussion of this topic. So this is a flowchart we've been using. We're done with risk analysis, and now we're going to talk about risk evaluation, risk control, and residual risk to conclude our discussion. So risk evaluation, for each hazardous situation, we evaluate the estimated risks. Is it 0, 1, 2, 3, is it 1 to 5, the scale we used before? We determine if the risk is acceptable or not. And if it's acceptable, we document and we stop. If it's not, we take risk control activities to reduce the risk. We may have to eliminate functionality or take other steps. And at the end of the risk control process, what's left is what's known as the residual risk. We'll come back to this. So in the next step, we have to talk about what is acceptable risk, because that's an important concept here. So what's the acceptable risk level? This is project categorization specific, and it depends on the situation and often results from a benefit risk analysis. So what's the benefit of the use of the software? What is the level of risk involved in the use of the software? And if the benefit exceeds the risk, then we can live with a certain level of risk. And there are many high-risk operations that are deemed acceptable. To give a trivial example, there are many medical procedures that have a high probability of the patient dying, but if the patient has a higher probability of dying, if absent the procedure, then the risk in those procedures is acceptable. Conversely, that risk is not acceptable if the patient is under no risk if we don't perform the procedure. So we perform a risk evaluation, now we're ready to do risk control. There are three fundamental techniques for risk control. The first one is that we change the design to eliminate the probability of the hazard occurring. So let's say we have an automated algorithm to detect, to do something, to guide a procedure. Let's say that there's a high probability of failure of this algorithm. It may be that the solution is we eliminated the algorithm. We eliminated this functionality from our device, or we change it to what? To make it more semi-automated with a user in the loop. So this changing of the design may eliminate the possibility of the hazard occurring. That is by far the best way. If you can do this, you should. The second method is to add preventative measures in the software to eliminate or reduce the probability of harm. We'll see an example of this in our image-guided neurosurgery example in a couple of weeks, where we perform the procedure and we have a set of checks and balances to make sure the user checks the results that they are correct. So here there's still a probability of harm occurring, but we add steps in the process to reduce the probability of the harm. And then the last one, and this is the one you should use least of all, is you add safety information measures. Warning, this can fail. So here's an example of that you have all seen. This is a coffee cup from your favorite fast food restaurant. It says, "Caution, I am hot." This is a risk control method of the safety information kind. To talk a little bit about risk control and the issues involved, here's a final clip from Mr. Rich Wincoop from Vision 28.
14971, which is the ISO risk management standard, has a clause in there that says risks are to be mitigated as far as practicable. What it means is you need to reduce your risk as far as possible, and that may mean that if you have a risk that can't be fully mitigated and it has very serious results, that at least you will have a multi-failure point safety margin in there.
So in general, if we think about this process, we can think about eliminate, reduce, warn. Those are your three techniques. And you want to eliminate first, reduce second, and warn third. In that order, that is the best practices for this process. So the final aspect of this process is post-risk control evaluation. We have taken our measure, we've added our warnings, or we've reduced the risk, and now we repeat the risk analysis to ensure that the residual risk is acceptable, the risk that remains after we've taken our measures. If not, we may need to take additional control measures. We may need to try harder. And sometimes we find ourselves at a dead end. The risk is not acceptable according to our criteria, but there are no additional risk control methods possible, practicable. And at that point, we may need to perform additional benefit risk analysis to determine if the residual is acceptable. Maybe we're too conservative before, or it may mean that we go back and change our design and eliminate this functionality altogether because we cannot keep the risk level down to an acceptable level. So to conclude this week's segments and this discussion of risk management, one of the things about risk management is that when it succeeds, nothing really happens, right? Risk control is similar to software testing. Both are what we would call negative activities. They prevent bad things from happening. They're not enabling interesting, useful functionality. This is not the thing you put on your commercial. these negative activities do not help with the marketing of the software in the short term, but in the long term, they create a reputation for quality. You trust this company because your software doesn't fail. And to summarize the topic, there's a good quote, this now is particularly timely, this 15 years ago, from Michael Levitt, who was the Secretary for Health and Human Services. He's talking about pandemics, but you can extrapolate the comments forward. So he said this in 2007, everything we do before a pandemic will seem alarmist, everything we do after will seem inadequate. And so risk management may seem alarmist. It's a process that slows you down. It adds all these extra checks and balances, all this worrying, but if you do it right, then you don't have to worry about something going wrong. And if something goes wrong, everything you did before in your risk management will seem inadequate, and you wish you would have done a lot more. So this concludes our discussion of this support processes for medical software. Next week, we'll finally actually start the process of designing software. We'll talk about the medical software lifecycle process and begin to work through the actual software creation process. Thank you.